Hi everyone, this is Annie from Hangzhou-MedX, and today let's explore some fun facts about DNA electrophoresis, what are its principles, and also the procedures of DNA electrophoresis in biological laboratories. So first of all, what is the principle of electrophoresis? The phenomenon of charged particles moving towards electrodes with opposite electrical properties under the action of an electric field. Electrophoresis is the technique of using charged particles to move at different speeds in an electric field to achieve separation. The movement of DNA molecules in agarose gel is determined by mainly three factors, and there's a hint here that agarose gel is the gel that we mainly use in DNA electrophoresis. So the first factor is the effect of the charge. DNA molecules carry a negative charge in pH solutions above the isoelectric point and move toward the positive electrodes in an electric field. And secondly, the effect of the molecular sieving. Under a certain electric field strength, the migration speed of DNA molecules depends on the size and configuration of the DNA molecule itself, and the migration speed is inversely proportional to the logarithm of the molecular weight. Therefore, DNA size can be determined through DNA markers. And here's another hint that DNA markers will be explained later in the video, mainly on the experiment part. And thirdly, factors affecting the mobility of DNA molecules. The size and conformation of DNA molecule, gel concentration, voltage, and composition of electrophoresis buffer. Specifically, covalent closed-looped DNA will have higher mobility than linear DNA, and then they will have higher mobility than the open-looped DNA. And next, what are the procedures of DNA electrophoresis in a biological laboratory? And actually, in our laboratory experiment, we actually apply DNA electrophoresis for several times, and let me explain the specific procedures later. So there are some materials needed for this experiment. They are agarose, which can be the solid ones, and also TAE electrophoresis buffer, 10,000 times georad. They are the EB substitute, since we all know that EB is highly dangerous and it may cause cancer. And there's a substitute of the georad here that we used in our experiment. And next, the DNA markers. And lastly, the sample that we used to test the DNA. Step 1. Preparation of 1% agarose gel. Weigh 0.25 grams of solid agarose and put it into a conical flask, and add 25 milliliters TAE, the electrophoresis buffer, and shake the conical flask evenly. Put it in the microwave and wait for the agarose to melt. Step 2. Preparation of gel plate. After cooling down the agarose solutions to around 50 degrees Celsius, add 2.5 milliliter of georad. Shake well and pour onto the electrophoresis gel plate. Pull the plastic comb vertically and gently after the gel has cooled and solidified. Place the adhesive plates in the electrophoresis instrument. And here's step 3, sampling. Use a pipette to add the sample into the small groove. Step 4. Electrophoresis itself. Power on the gel plates after adding samples for electrophoresis. It can be set to around 120 voltage in 30 minutes generally, especially in the situation that we have 1% of agarose gel, and it will be set according to gel concentration and sample size. Step 5. Observation. Here's this final step. After electrophoresis, observe the plates under a 154 nanometers ultraviolet lamp. Compare the graph with the DNA markers beside. And thanks for watching this video of explaining the procedures and the principles of DNA electrophoresis. And remember to follow our channel, Hangzhou-MedX. Thank you. Bye.